There are two model sets that I found to be particularly helpful for illustrating traditional seismic trace attributes. The first set incorporates no geologic tuning. It focuses on amplitude, bandwidth, and phase variations in the seismic wavelet. The second set flips the focus. It maintains a constant seismic wavelet but shows the effect of variable thickness. Let's look at the first set in more detail. These 7 models consist of 9 traces with a single reflectivity spike that's been processed in various ways. In each case, combinations of energy, bandwidth, and/or phase vary linearly from left to right in a predictable and identifiable way. The first 3 models are the simplest cases, in which only one variable changes at a time: reflection strength, bandwidth, and phase. The remaining models consist of combinations of the first 3. For example, reflection strength and bandwidth, reflection strength and phase, bandwidth and phase, and last but not least, all 3: reflection strength, bandwidth, and phase. When examined as a set, these 7 models illustrate sensitivity of attributes to effects of processing with no tuning effects. In other words, constant geology, variable wavelet properties. The second model set flips the variables. Instead of constant geology and variable wavelet properties, we now have constant wavelet properties but variable geologic tuning. And this comes in the form of 3 wedge models. To model sub-resolution thicknesses, each wedge is filtered with a zero-phase Ormsby filter. In the blocky case, each trace contains 2 reflectivity spikes of equal amplitude opposite sign. In the blocky gradational case, all samples within the wedge are filled with a low-level positive amplitude. Each trace also contains a negative spike at the top of the wedge. In the gradational case, all samples within the wedge are filled with a low-level positive amplitude. It is helpful to examine both model sets because seismic attributes respond to both processing effects and geologic effects. The first model set exhibits laterally consistent reflectivity but laterally variable signal properties. The second model set exhibits laterally variable tuning but laterally consistent signal properties.